then majority of the current passes to RE only. That is again wrong design. But if you go with this equation, XC much less than RE, definitely almost all the current will flow through C. Much less, kitna? Then you have to use the approximation. And in the design, almost 30 to 40% approximations are there, assumptions are there. So if I take XCE, say 1/10 of RE, okay, the major current will flow through C. Everybody is fine. So based on that, you can select the component C. Right? So what is the circuitry we have known? That is the final circuit for a single stage RC coupled circuit. Okay, no, it is not a biasing circuit, it is single stage RC coupled. Alright. So again, very quickly, just you describe the functions of all the components. Okay, so this is your circuit diagram. The next point you can write as circuit details. Under circuit details, you can write in very brief the functions. So if we start with this Vs, what is Vs? External AC signal which is to be amplified. You can write that. Rs is the internal resistance of the source. It is internal resistance of the source. Now if its value is not given, you can assume this value in the range of few ohms. The value is not given, you can have that range 50 to 100. Now what about the R1, R2? These are voltage divider biasing resistors. R1, R2 are the voltage divider biasing resistors. RC is the collector load resistance. RC is collector load resistance. Its meaning is very important. In the absence of external load, it will act as a load resistance. It will act as a load resistance. Then you have RE. What is RE? Emitter stabilizing resistor. RE is emitter stabilizing resistor. RL is external load resistance. Now come to the capacitors. CC1 and CC2 are the coupling capacitors or blocking capacitors. CC1 and CC2 are coupling capacitors or blocking capacitors, whereas the CE is emitter bypass capacitor. CE is emitter bypass capacitor, and whatever your T is there, that is the NPN transistor. Okay. So if you select another number which corresponds to PNP, okay, only change that you have to do is just change the supply. Everything is fine. With the same components, the available transistor, if it is PNP, you have to change the supply to minus VCC. Okay. and VCC is the power supply. So what is the function of these two capacitors? So let us imagine that this capacitor is not there. What will happen? This will pass, that means this wire will pass AC as well as DC. Whereas you need purely AC there. Okay. That's why this capacitor must be there. And that is the reason why it is called as a blocking capacitor. It blocks the DC. Similarly, if this capacitor is not there, again some DC will pass through AC input signal. That will disturb that function unit. Okay, so that's why CC1 is must. Okay. Now before we go to the problem, so let us cover one more thing, that is the AC equivalent circuit. Now if the question is analyze single stage RC coupled amplifier. See, the very important question. The term used is analysis, analyze. So analysis stands for calculation of different values. Like say I have to calculate voltage gain, I have to calculate input output impedances or resistances, I have to calculate the bandwidth and so on. Calculations of various parameters stands for analysis. And for this analysis, there are two methods. First method is a graphical method. What the second method is there? The second method is called as H parameter method. H parameter or equivalent circuit method. Now for this graphical method, what we require is the graph. What we require is a characteristic, output characteristic. What are the characteristics we have drawn? That characteristic is required. And the complete analysis is divided again in two parts. One is the DC analysis, next one is the AC analysis. Okay, so this analysis is in DC analysis first, and secondly we'll go for AC analysis. Already we have covered this DC analysis. यहाँ से क्या करना है? What we have to cover? Here you have to draw a DC load line. Already we have drawn. Then we have to fix a Q point. That means up to fixation of the Q point at a correct place. That is the DC analysis. Once your Q point is fixed, then you have to switch over to AC analysis. Okay. For DC analysis, you have to follow certain steps. AC supply should be removed. Now, what are the capacitors are there? Capacitors should be open. Under DC condition, reactance offered by all these capacitors. वो कितना रहेगा? Reactance कितनी? Infinite. Xc is equal to 1 by omega c. 1 by 2 pi f into c. So reactance equal to infinite means the capacitors are open. So your basic circuit changes to voltage divider network only, which already we have covered. Okay. So from that voltage divider circuitry, which points you have to cover? DC load. Just apply the KVL to output section. For Q point, apply KVL to input section. Find out base current. Then the intersection of the base curve with the DC load line, you will get it. As far as the AC equivalent circuit is concerned, AC analysis is concerned, you have to remove the DC supply. Okay? Very first step, you have to remove DC supply. And by assuming the suitable frequency range, you have to replace capacitors by short circuit. Here assumption is frequency range. Frequency range is mid or high. Right? So why capacitors are replaced by short circuit? So once again, reactance of capacitor is 1 by 2 pi L into C. If the frequency is in this range, mid or high frequency, the denominator term is on higher side. So overall XC is less. If the reactance is less, you can replace it by short circuit. If the reactance is more, you have to remove it, you have to open it. Everything is fine. So now if you apply those steps here, so how is your equivalent circuit now? क्या करना है first? Remove the supply. I will remove this one. Next step, whatever these capacitors are there, these capacitors are replaced by short circuit. Right? So how is the circuit? This is as it is. What about these two? See, this point is common, ground and ground. This is another common point for R1 and R2. Means R1 and R2 are in parallel. What are the AC signal is there? That is Vs. What next? The transistor. Okay, so drawing equivalent circuit is very simple. Just you get the fundamental basic things, you can easily draw. यहाँ से क्या होगा देखो, from emitter you have one resistance, and across that resistance you have a wire, short. So what is the equivalent resistance? Is zero रहता है. Short means zero. Zero into any resistance. That is zero that comes here. That is zero in parallel. Now from the collector, you have the two resistances. Whatever the another point is there, that is grounded, common. That means this RC and RL are parallel. And this RC parallel RL gives the AC load, that is nothing but RAC. And across this RAC, you have to take the voltage. So this circuit is AC equivalent circuit of the given, of the single switch. Okay, so we have to ground it. Okay, that means for complete analysis you have to cover both the steps, DC and AC. हमारा ये चल रहा है graphical method. Okay, as far as this method is there, only one step we have to add. What the transistor is there, that should be replaced by its model, H parameter model. If you replace that one, you will cover that equivalent circuit method. Okay, now some logical statement I will make. What is the slope of DC load line? Minus 1 by RDC, where RDC is RC plus R. Now, equivalent to this one, logical statement is slope of AC circuit should be minus 1 by RAC. DC load line से कितनी slope होता है? और DC load line slope is minus 1 by RDC. So for AC load line, I can make the statement minus 1 by RAC. So whether RAC is known, what is RAC? RAC is nothing but RC parallel RL. Now if external load is not given, हा दिलास नसता तुम्हाला. So whether your load is infinite, see this is the typical orientation. If external load is not given, does it mean that your load is infinite? No. Immediately you have to recall the equivalent circuit. And in equivalent circuit, what you will get is simply RC. हा point between collector and ground, you have RC. So that's why the description of RC, if you recall it, it is collector load resistance. And in the absence of external load, it will act as load resistance, because in that case the voltage is coming across RC. Okay, so you should know the basic thing there. So this is RF, this is RC. समझते हैं ना का कंट्रोल है? So if you get tired, then we'll stop. Tell me. Okay, that means whatever slope is there, that slope is minus 1 by RC. Now the question is, if the slope is given, can you plot a line? Okay, so slope, lines of slope here, minus 1 by RAC. That means if RAC with known RAC, your slope is known. So can you draw a line? So you have the axis, say IC axis and VC axis. So which question I have raised? If the slope is given, can you plot a line? The answer is yes, because this RAC is nothing but V by I. I mean, what the slope is there, that is nothing but I by V. So slope is known and I and V are unknown. So if you assume for one quantity, you can calculate the next. Very simple logic. The slope is given, so this equation turns out to be I by V. This value is known. Because we know RC and RL. Okay. Now if I assume say V is equal to 1 volt somewhere here, V means V is equal to 1 volt, I can calculate the R. And if I join these 2 points, I will get a line for desired slope. Is it the AC load line? We have to think. Because the condition for AC load line is slope is minus 1 by RAC. But this is not the complete requirement. Because see, AC stands for, pay attention now, AC stands for a signal like this one. Right? Now whatever this point is there, if you think of this point very carefully, the points like this one. That means in this circuitry, if you have input signal, now tell me the conditions at these points. यहाँ पे कौन सा condition है circuit का? AC तो zero है यहाँ पे, but still that DC is there. ये DC short कैसे set के लिए अपन? Only for analysis purpose. Practically ऐसा नहीं करना है. I want AC analysis, so I will short the supply. Then I will take the reading. Is it the way? Definitely not.